Good evening to all of you. You all are welcome to my channel. I am Tamujit Pal and today I am going to deliver a lecture on magnetic effect of current. So before jumping into the topic, let us make some understanding about this magnet. What is magnet? When it was discovered? Where it was discovered? So what is magnet? We all know the magnet and we all are familiar about this magnetic property. And many of us have seen the magnet. Okay. Now, we all are familiar with this magnetic property. But if we travel 2000 years back, when the magnet was not discovered, at that time, this magnetic property was peculiar property for them. So basically, the magnet was first discovered in Greece. In Greece, there was a place named Magnesia. There, the people they found a black color stone which had a peculiar property that it attracts the iron field. Because that property at that time it was not familiar for them. So they found a black stone. So Magnesia was the place where the magnet was first discovered, and it was in Greece. And there they found a black color stone. Later, this black color stone was named as magnetite. Actually, this magnet, the name comes from the word magnesia, the place where this magnet was first discovered. Okay. So we have learned the discovery about the magnet. Now after this discovery, this peculiar type of behavior, they started exploring this behavior, and they implement this magnet in their day-to-day life, and they evolved in this field. Now the time came. Now the time 1680. 1680. In 1680, a person named William Gilbert. He was basically a physician of Queen Elizabeth of UK. So he was a physician, and he was the first person who discovered artificial magnet. Who discovered the artificial magnet? So this was all about the history of the magnet. Now I am entering into the chapter. So the name of the chapter is magnetic effect of current. Magnetic effect of current. Many of the scientists they came into the field and made a rigorous research work and developed this magnetism field. So this magnetic effect of current. Actually, it was an accidental invention. It was first invented by a scientist named Hans Western. Hans Western was the first scientist who accidentally discovered this property. What is that property? That suppose this is a conductor. And here a magnet. Here a magnet is placed just under the conductor. Now if we pass a current I through this conductor, then this magnetic needle will deflect. This magnetic needle will deflect. Why it is deflected? Actually, this is a magnet. Now, a magnet can be influenced by a magnetic field only. So, from this experiment, the scientist Western he came to be know- he came he know, he discovered that this current carrying conductor will produce a magnetic field. Will produce a magnetic field. We will discuss this experiment later. Let us first do the chronological discovery in this field. So first, the scientist who discovered this magnetic effect of current was Hans Weierstrass. Now the scientist came into the scene will be Ampere. Ampere said that the current carrying conductor will produce a magnetic field and this current carrying conductor will produce a magnetic field. This thing was discovered by Hans Weierstrass. Now Ampere said that this current carrying conductor will exert a magnetic force. Basically, this current carrying conductor will produce a magnetic field, and this magnetic field will exert a magnetic force. Okay. So basically, he said that this is a current carrying conductor I. Now, if there is another conductor which is carrying current I1, this conductor number 1 will exert a force on the conductor number 2, and this was discovered by Ampere. Fine. Ampere also he made another statement that this magnetic property where is the source where is the source of this magnetic property? He said that if we go to the atomic level, subatomic level, if we go to the subatomic level, then inside an atom there is a nucleus. Inside an atom there is a nucleus, and around this nucleus electron is revolving. Around the nucleus electron is revolving, and this revolving electron will produce the magnetic effect. Okay. So these two things was discovered by Ampere. Actually, these two things was added by the Ampere. Okay. Now the scientist came into the picture was Faraday. Faraday said that if we change the magnetic field, then this changing magnetic field will induce an electric field or induce an EMF. We will discuss this Faraday's law in the next chapter, but these things was discovered by Faraday. So Faraday discovered that changing magnetic field will induce an EMF phi. Okay? So this thing was discovered by Faraday. Now came was Maxwell. So Maxwell, he was a great scientist. He did a lot of research in electric field and magnetic field, in electricity and magnetic field, and he just merged these two fields. By giving the four equation, the four famous equation of Maxwell. Now, in this chapter, after Faraday came was Maxwell. Maxwell, he just add one extra statement. He said that this changing electric field will induce an magnetic field. This changing electric field will induce an magnetic field. So this thing was added by Maxwell. So these are the four scientists who played a important role in this chapter, and these four scientists laid the foundation of this magnetism chapter. Okay. Now let us study about the detailings of the Oersted experiment. So detailing of the Oersted experiment. Now, Oersted said that if a conductor carrying current I in this direction, then the magnetic field will deflect it. Now, in which direction this magnetic field will deflect? Now, in which direction this magnetic field will deflect? This will deflect in this direction. Here it is. Here it will be North Pole. And here it will be South Pole. In which direction this magnet will be deflected? Now, according to Oersted experiment, he said that let us take the pump and place this forefinger along the direction of the current, and if we stretch the thumb, then this thumb will give the direction of the magnetic field. What he have said? He said that place the pump in such a way that this forefinger will show the direction of the current. Now, this thumb which is stretching outward will give the direction of the magnetic field. So magnetic field will be deflected in this direction. Okay. So this was the Oersted experiment. Now, if we change the direction of the magnetic field, current, if we change the direction of the current, then what will happen? Place the pump in this direction such that this forefinger will show the direction of the current, and this outward thumb will show the direction of the magnetic field. So in this direction, this magnet will be deflected. Okay. So this was the Oersted experiment. And why it is happening? It is happening because the current carrying conductor will produce a magnetic field, and this magnetic field will deflect the magnet. Okay. Now, in this context, Ampere came and Ampere gave this. Ampere gave his swimming rule. Ampere's swimming rule. He said that if we swim towards the direction of the current, suppose this is the direction of the current and we are swimming in this direction. Okay. Current is flowing in this direction and we are swimming in this direction. So my head will be directed towards the flow of the current. Now, in this position, my left hand will give me the direction of the magnetic field. Suppose my current is flowing in this direction and I am swimming towards the direction of the current, so my head will be towards the direction of the current. So in this direction, now see, my left hand is in this direction, my left hand is in this direction. So in this direction, my left hand will show the deflection of the magnet. Okay. So my left hand will show the deflection of the magnet. So what he is saying that this is the current I. Now we are swimming in this direction. That is towards the flow of the current. Now this is the left hand, and this left hand will show the direction of the current. This is the direction of the magnetic field. Direction of the deflection of the magnetic field. Direction of the deflection. So magnet will deflect in this direction. Okay. Magnetic North Pole. Okay. So this is the Ampere's swimming rule. This is the Ampere's swimming rule. Now, we have done with the introduction of this chapter. So in this introduction we have learned that what is magnet, how it was discovered, when it was discovered, where it was discovered, when the artificial magnet was discovered. Now we have learned the four name of the scientist. Okay, four name of the scientist. Okay, who played an important role to build up the foundation of this chapter, and what they have discovered we have learned. Now after that we have made a detailed explanation on Istad experiment, Faraday's experiment, sorry, not Faraday's experiment, Istad experiment and Ampere's swimming rule. So this is the introduction of this chapter. After that, in the next video, we will learn about the magnetic field, magnetic force, different magnetic field for the different geometrical figures. So this is all about today, and in the next video we will learn about the remaining chapter of this syllabus.